Example 3 for modeling real life. We're going to be looking at this blown up version of a computer chip. This is actually much larger than what they are like in real life. But it tells us here that the scale drawing of a square computer chip helps you see the individual components on the chip. So they kind of zoomed in on it. And it's not necessarily to scale as far as this ruler is concerned. It's enlarged a little bit. So this is not a true centimeter, but it is acting as a centimeter for the purposes of this problem. When I flip over to my camera, I can show you that a real centimeter is about the width of your pinky nail from here to here. That's about a centimeter. So when I put that here, you can tell that that centimeter is just a little bit larger than the width of my pinky nail. And as far as millimeters are concerned, that's about the width this way of your nail. Okay, I'm trying to show you, but so the width this way is about a millimeter. So these are definitely just a little bit more blown up here for a millimeter. And there are 10 millimeters in 1 centimeter. So this would be 5 millimeters, 6, 7, 8, 9, 10. So that's our quick review on the centimeter ruler. But going back to the problem, we know that this is a square computer chip, and it's asking us to find the perimeter and the area. So when we hear perimeter, we should think add up all sides. And when we hear area of a square, we think length times width or side times side. Either one of those. So it says find the perimeter and the area of the computer chip in the scale drawing. So here we see the scale, and it's always the scale model to the actual, right? So this is the one they're talking about because it says in the scale drawing. So we're looking at the 1 centimeter. So we're measuring the side lengths in centimeters, which is why we have the ruler here. And the length of this side is 4. So the length of this side would be 4 centimeters as well because it is a square and all sides are equal on a square. So to find the perimeter, we add up all the sides. 4 centimeters plus 4 centimeters plus 4 centimeters plus 4 centimeters is equal to 16 centimeters around the computer chip for the scale drawing. We could have shortened that by saying 4 times 4, which is still 16 centimeters. For the area, that's equal to length times width, or side times side, and because it's a square, they're both 4. So 4 centimeters times 4 centimeters. So because it's area, it's 4 times 4, which is 16, but centimeters times centimeters is centimeters squared. So even though the number itself is the same, the fact that this the perimeter is just counting each individual centimeters, here we're multiplying the centimeters as well. So the area is 16 centimeters squared, and the perimeter is 16 centimeters around. In question B, they're saying find the actual perimeter and area of the computer chip. So to do that, I have to calculate this here as a rate and change it to the 4 centimeters here that I'm given because I know that it's 4 centimeters long. So to do that, another way I found that was by multiplying by 4. So I have to do that here to the actual length as well. So my 2 millimeters is actually representing 8 millimeters on the actual object. Okay, and so to find the perimeter, we're going to add up all the sides, which would be 8 plus 8 plus 8 plus 8, which is 32. Oh, not centimeters, excuse me, millimeters around the actual computer chip. And again, that could have been found by doing 4 times 8, which is 32 millimeters. The area would be your length times your width. So again, it would be 8 times 8, which is 64. And then millimeters times millimeters would be millimeters squared. So our perimeter is 32 millimeters around because this 4 centimeters is actually, when I calculated, it's 8 millimeters in the actual, when I multiply them both by 4. And then I use that 8 to find the area.